All right, welcome. We are COMP123 in the summer 2020 semester, and it's week 6, part 1 of our broadcast. It's actually part 1, and we may not have a part 2. We'll see how it goes. But we have to talk about this. So I just wanted to bring it to your attention that this Wednesday, just in case you've forgotten or you don't know, but if you notice July 1st, if I click on July 1st from a calendar perspective, it says Canada Day all day. And that means that all of us are off on Canada Day. So there is no classes. There are no classes on Canada Day. So what happens to the recordings? What happens to all the lecture stuff? I'm going to see how things go. But if we need to, what I might do is add a recording at a later date this week, as an example, and then share that with you on eCentennial. All right, so again, I'm going to try not to, because what that's going to mean is more work for you. If I record something, that means you're going to have to watch it, and because it's going to be included on different things, right? So I just wanted to bring that up. Also, we have to talk about assignment 2 a little bit. I know that depending on how you hand things in, you need to hand in your .zip file. So what I highly recommend, I'm just going to go to the web here, is please use 7-zip. All right, so 7-zip is a free utility. I kind of mentioned this before, but I highly recommend 7-zip instead of your built-in compression, decompression in Windows. It doesn't work as well, I find, as 7-zip. It's a free download. Download the 64-bit version and install it. It just makes life easier. Also, please, I will not be accepting a RAR file. So if you hand me RAR files like .rar, I will not accept those. Please do not hand me RAR files. Okay. So so if you go up online now, if you go to the assignment details, and again, let's just look at that. So let's look at assignment 2. And hopefully it's going to have some details in here for you guys. It says rename the program file CS file to filename.cs, firstname.cs. To me, I don't really need this part. What I need more than anything else is, because you don't have to do this for me, what I really need is, so I'm going to say submission details here. This is on your assignment 2, right? What I'm looking for is a zip archive of your project folder. So your solution folder. So that means everything. Please don't just give me your solution file. If you just give me your .sln file, you will get 0. Okay, I have to have all your files. So that's the first thing you need. I would like for you guys to practice and give me a link to GitHub. Okay? And when I put this as optional, I would like to, and what this will do for me is it'll make it easier for us to, for me to mark your work, which is what I'm looking for, right? So that's what I'm going to say in terms of what I'm looking for assignment 2. So those two things are generally what I look for. And if you look at the, I'm going to save that. If you look at the document, so let's take a look at the PDF together for a second. I know people were asking questions, so I wanted to kind of go over assignment 2. So the assignment attempts to model the social phenomenon, involves an enum and 2 main classes, audience, TikTok, and the TikTok manager. It's not bad. You will load a set of TikToks from a local file into a list collection. You'll perform simple queries on this collection. TikTok and the TikTok manager class must be in separate files and must not be in the program.cs file. Okay, so this is important because I know some people are used to putting multiple classes in one file, and the audience enum, it says may be implemented in the TikTok.cs file. All right, so that's interesting. I personally prefer enums to be separate, and we'll talk about that today, right? And what Professor Nardo has done is he's gone through and he's given you the marks, the mark breakdown, and the enums that are in here. Again, this is kind of like the name, audience, type, enum, and the constants, world, group, and special. Okay, and then from a TikTok class perspective, right? He's talked about the class. There is what looks like a private field, right? ID, which is of type int, and then a bunch of public properties. So, and they're only, if you notice this, set or absent, right? So that means that you can only, these are read-only properties. So originator, length, hashtag, audience ID. These things here are only read-only properties, right? And there's a few methods here. So there's the constructor method, which is called TikTok, and it takes in the originator, length, hashtag, and audience. So this part right here is all the stuff that it takes. When you create again, there's two constructors here. So one of them takes those, and the other one takes all of these. And notice that there is the alternate constructor has, so one is an audience type. Audience type means that you must use an enum, right? That's what that is. And then there's another constructor type, where the audience can also be a string. So those are the two different types that you can have, right? And with this constructor, you also have to input an ID. So those are the two options for constructor methods. Now we have the overloaded toString method, which you must do, as well as something called a parse method. Okay, here's the parse method. It says the $sign symbol is used to denote that a member belongs to the type rather than a specific object, and you must use this type to access that member. So what that means is this, chances are, is a and so is this. So this is a private, from what it looks like, a private static field. That's what this looks like, right? And this looks like a with a $sign, and this looks like a public static method. All right, so that's what these two look like. I'm going over to you because I know some people have been asking. And then it tells you what to do here and what these things mean. And if you scroll all the way down, there's some, it talks about the TikTok class itself in more detail. Again, he's gone and done a lot of good work here, Professor Narendra, and giving you a lot of detail. Please read through your assignment 2 to make sure that you check off each of these different pieces to make sure you have these things. So when I mark it, I'm going to go through each of these parts and say, okay, do they have this? Do they have this? Do they have this? You'll start at a 100%, and then I'll work backwards. So I'll just subtract stuff until you have whatever your mark is. Okay, that's how I normally mark. So please, what I'd ask you to do is submit a zip archive and an optional GitHub link. That would be nice, since we're using GitHub anyway. All right. So that is programming 2. This is worth 50 marks. Is 50 marks out of 50. That means if you get 48 out of 50, it's 96% and so on. Okay, so make sure that is what you're doing. Questions around assignment 2 and when it's due. Again, this is due for what it looks like. It says the end of week 6. End of week 6 for me means Sunday. All right, so that's when that's due. Sunday at midnight is I think when it's due. Okay. All right, so that's assignment 2. So again, it's up there. I want you. I know one person has submitted already, but there's if you haven't had a chance to already, I would definitely start on assignment 2. Please don't wait. The other thing I'm doing is for this week. So this is our GitHub repo, and inside of our content area, under week 6, I've got two things. I've got our lesson 6A as well as this YouTube link that you're watching right now, if you're watching it. I'm also going to put in a link to our current repository. All right, so this is GitHub repo for week 6. Now I'm gonna I gotta admit something to you, that the GitHub repo for week 6 is just a copy of the GitHub repo for week 5 with some minor changes. So that's what we are. I'm just moving off of what we did last week with lesson 5, and I'm just continuing with the same project for and for the most part with lesson 6. Okay, so that's what I'm doing. And how did I do that? Well, here's Visual Studio. Notice that I just I copied it. So in my from a file perspective, so notice here's repos. There's part 5. There's lesson 5. There's lesson 6. All I did was copy lesson 5 to lesson 6. That's what you can do. And then what I did is I didn't rename anything out here. This is a bad thing. Don't rename stuff in here, right? Notice that this still says lesson 5 part 1 inside from a folder perspective outside here, right? If you rename this, bad things would happen. However, if you rename it inside of Visual Studio, which is what I did, I renamed this to part 6 and this to part 6. It shows part 6 with the same stuff. The next thing, of course, to do is run it to make sure that it all works. So once you've done your renaming and copying and whatever, you can see still we're all good to go. Fat bullet, the boss, and whatever, right? So this is our example that we've been using for the last couple weeks. And again, I've brought this to you guys because I wanted to make it a little bit more complex, and we do have several classes that are in different files, so I wanted to get you guys used to this, this kind of structure. So what are we talking about today? Well, we're going to continue with that whole abstract inheritance, abstract classes, and interfaces today is where we're moving into, which is just another part of that same lecture. I've just broken it down here into this. Where we're supposed to be today is exception handling, and we're way over here in inheritance. And if you go this one out, there's another piece that's missing from this one, which is polymorphism in the second half, right? So I'll be sharing that with you as we go forward. Now, don't despair. You're not going to lose out from doing exception handling or file I/O. So none of that stuff. We're actually here. There we go. That's where it should be, not 5, 6. I'll be okay. So if it says 5 in your PDF, it means it's really 6. Okay. So this is where we're supposed to be, file I/O and serialization. We're going to get there. All right. We're going to get there. And from a file I/O perspective, if you load stuff from a file, it's not that difficult to do. In fact, C# has a bunch of different ways of doing it, and we're going to cover file I/O and serialization as we go forward in with our user interface stuff in the second part. All right. So again, just for those people who came in late today, again, try and make it on time for class, and only because you might miss out from what I've said, you might have to watch the video afterwards. But one thing to note is, remember that Wednesday there is no class. So there's no class on Wednesday. I've kind of sent that to you guys in an email too. Please make sure you understand that for our class. Okay, let's continue. So we talked about interfaces, and what I'd like to start talking about is this, inheritance. And what I want to start talking about with you guys is this notion of abstract classes and interfaces. I'd like to try and hit extension methods today if we can, and this is an interesting concept. But remember how things work from a class, an inheritance perspective. So if I was to, let's bring this up for a second and see if we can do this nicely. So remember our diagram. It's pretty simple, right? We have a kind of a class, right? Here's our base class. You can call this our base, and I keep drawing this over and over again to help you. To remind you of how things work. So here's our base class, and then we have our child classes. So again, let's make this like this. So here's our, let's say we have a child class here. And I remember the other thing is we talked about that the child class itself has a the child class is fatter than the base class all the time. That's how it always works out, right? So that's important to remember, right? Because that's, people forget. They're like, child class, child means small, right? And it's not true. A child actually for object-oriented programming means actually bigger. Why? Because there's more specialization. These children, right, are more specialized than the base class. And if they're on the same level like this, right? Because a base class can be a base class and also a child class. And we saw that already with our enemy class, right? So that's something also to note. So here we have two children, like a tree-like structure, in this case, a binary tree, right? Where we have two different branches. This is one branch of development, this is another one. These two children have, even though they're on the same level, they most likely have different specializations than one another. They're not the same, right? Even though they might be called different things. You would never make the exact same child with the exact same stuff. Otherwise, there's no point making two children, right? And these are blueprints. We talked about blueprints, right? So whenever I make another child, I make an object of this child class, whatever this thing is, right? But we have a situation where our base class, the one we have right now, which is called GameObject, all right? So let's just put this in. Here's our current situation, right? Our GameObject superclass or base class right now, it doesn't mean anything. And let me explain this for a second. GameObject is so generic, it reminds me a lot of the person, superclass, right? So if I looked at person, right, as an example, person doesn't it doesn't have a lot of contextual meaning, person. Whereas student has a lot more contextual meaning. So if, let's say, for example, we're not doing the, I'm not going to use the GameObject just for this example, all right, just so that we're good to go. So I'm just going to cross it out here. So it's not GameObject, it's person class. Doesn't matter what it is in the base class, right? And now if we think about one of our child classes, one child class is the student class, right? Which is very different than the teacher class or instructor class or professor class. Let's make it a professor, all right, in this case. So here's our professor class, all right? So they're both children of the base person class, right? Professor has context, right? There's almost like a job. Person doesn't really have a context. Person's very generic, right? Person can mean anything. So because person is so generic like this, typically, we would never really instantiate an object of type person, not in real life, right? And when you're building a class structure like this, right, what you want to do is avoid general classes like this. You don't want to make a general class called person because it can be used in different ways. And you're going to make a structure for your application that you're going to share with other users, chances are. And in a real life environment, those users would share those classes with you, right? So you're going to access their application programming interface or API, and it's going to be made in a specific way so that you can use it, okay? So chances are, person is so abstract, it's so generic, you'd never make an object of type person. You make an object type student, maybe professor, but not person. We can go one level deeper. For example, student is also generic. It's more specific than person, but still quite generic in terms of student. I mean, this can mean anything, any kind of student. So if you think about this, and this is just from a business rules perspective, I'm trying to formulate or mirror the real world with some code here, right? So you're going to learn more about this when it comes to object-oriented design later on. But I can have another child of the student child class, because the student not only is a child, but it can be a base class for another type. So let's put that in there. So we'll say it is a child class, but it's also a base class, right? And we're going to make it, in this case, why? It's the child of this person class, but it's the base class for maybe other classes, because that's how inheritance can work. It's an inheritance chain. So let's call this other class, we have two. We talked about domestic student, right? So this is one type. We talked about this last time, domestic student. And we have another one. We have another one which we talked about as international student, right? So those are the two different kinds of student classes. Now, this is way more specialized. Domestic students more specialized than student, and chances are we would never use the student superclass or base class to make a to make an object, right? Why? Because domestic student is more specialized, and there's no need for us to have a student class if we have a domestic student class. When I say no need, I mean we need it because there's going to be some similarities, right? As we go forward. So let's talk about this as international student. So I want you to think about this for a second. And again, this is just context, right? So you got to think about planning a little bit. Imagine we're planning a large application. It's not a small application like this one, where you have many, many classes and many, many levels of classes, okay? So here, we talked about this before. I'm just going to make the arrows, these points. So let's just say, remember when we ever make arrows, they always point to the base class. Okay, so that's how it normally works. I'm just making them like this so they're connected. They're not normally like this. Usually they have an arrow like this and they're separate. But I'm making it so that you guys can see that professor class is definitely a child of the base class person. So is the student class, the child of the base class person. But now we have two more children, right? I'm making child capital C for some reason. I don't know why today, but I'm going to do it. So again, if you think about this as a binary tree for a second, just a second. I mean, it doesn't have to be binary. You can have another third class, another type of student too, right? Maybe there's a student teacher, or something like that. But there could be another kind of student, another type of student that we haven't thought about, right? And again, international or domestic student, we could break this down into levels. Like, for example, a domestic student that is, for example, a college student, we could break it down into college and university. There's different specializations, right? I mean, they're very similar, but anyways, you can see here in this case that this child is a child of the student class, which is in turn the child of the base class. We can say that, like we said before, and this is just a review, that we have an is-a relationship, right? So an international student is a child, right, or is a student. It is a student, right, international student. But the international student is also a person, right? Because we have this is a relationship all the way up. So the student is a person, the international student is a student, but the international student is also a person, right? Because of the inheritance chain, the way it goes up like this, right? We know this. And it makes sense. Like, you can actually say it in English. International student is a person. Yes, it's true, right? International student, but is not a professor, right? There's no relationship between international student and professor other than they share the same base class person, right? That's the only relationship these two have, right? Same thing with domestic student. Domestic student is also a student, and there's a closer relationship between international student and domestic student because they're both student types, right? They're both student types. So there's a closer link between these two than these two, than these two, even though they're all person type classes, right? They're all based on the person class. Okay. So I want to point this out because we want to kind of say, we want to make rules. Let's say, for example, you made this code and you said, you know what? I don't want anybody ever to make a person object because it doesn't make sense in my context, right? I don't want that to happen. I want people to make, right, only a domestic student and an international student, as an example, and a professor. Now, those are the three things I want them to make, right? But they can't make a student class by itself, and they can't make a person class, right? You can limit what classes can be instantiated. And we're going to talk about two different types of classes now. So now we're talking about class categories. One of them we can think about as an abstract class. We can still make it, right? We can still use an abstract class. So this is the abstract person class, right? We can still use that. We'll make one more abstract class. We'll say that the student class is also abstract. So why? Because we're not going to ever instantiate an object of type person, and we're not going to ever instantiate an object of type student. Just these specializations, right? And then the other type that we can make, right, the ones we can instantiate are called concrete classes. Okay? That's just the name of the type. So concrete. Okay? You can't create a concrete. Let's make that, copy that for a second. So domestic student is a concrete class. I want to make that one a concrete class. And I also want to make the international student a concrete class, right? And again, I want you to think about what this means. Concrete means you can make objects of that type. Abstract means you cannot make objects of this type at all. Okay, they're just used as blueprints only. So you can, and of course, to provide a base for both different kinds of classes. So notice like this abstract class can have another abstract class as a base. No problem. That's okay. Okay? But both of these two classes, this person class and this student class, can never be instantiated if we mark it as an abstract class. We can't. Okay? And there's a couple of areas of syntax that we have to modify to get there, and I'll explain this in a second. So let's go and talk about what an app. So basically, like we said, so one, which you cannot create concrete objects. Concrete class, concrete objects. Abstract class, no objects. You can't make objects of an abstract class, right? And sometimes what they have is we have abstract methods, right? So you can create a method header, a signature, but no implementation. So the method itself is empty inside, right? And you want your user to override it, right? You want it to be overridden. You don't want to define it in your abstract class because you know it's going to be overridden. So what you do is you mark it as abstract, right? And an abstract method has no method statements, like it says. It's empty inside. There's no implementation details for it whatsoever, okay? And if we mark a method as abstract, derived classes, right? So that means child classes, right? Must override using the override keyword. Must override. Okay? So that's something that we have to think about as well. So here's an example of an animal class. Remember, we just talked about this. Animal is so generic. It doesn't mean anything. Animal. What does animal mean? Nothing, really. I mean, it can indicate a lot of different things. We need more specificity, more, kind of a specialization for animals. So what we want to do is make a subclass or a derived class of the animal, or a child class of the animal, parent class, superclass. I'm using the same words because they mean very similar things in different languages, and I want to keep generic here because you're learning C#, but you can apply these same concepts to Java, C++, Python, other languages, okay, as an example. So again, notice that we have a public animal property. We have a private name string. Here we have a public string name. So this is animal is the public constructor, right? Animal of animal. So it takes the name as required, and also we can get the name. There's no setter for, so it's a read-only property for the name itself. And then we have this public abstract method called speak. Okay, that's interesting. So now here are two concrete classes. All right, dog and cat. Dog is still pretty generic. I mean, there's a lot of types of dogs. Very many different types of dogs. Look different. There's lots of stuff that are different kinds of dogs, right? However, they're still dogs, so it makes sense, right? And a dog is very different than a cat. There's different specializations. Not just the way they speak, meow and woof, right? We're not talking about these two things, but many other things about the construct of an animal as a dog or a cat. Size, their behavior, whatever. Okay. So, but notice that they both have the speak method, just like we had in the toString method, and we use the override keyword to change the output of this method, just like we do for the toString method. Okay, so that's very similar. Here, what we've done is in the abstract class, we just marked this as abstract, not virtual, right? Virtual we can actually override. So it's very similar to virtual, but when we mark it as abstract, it must be overridden. Okay? And here we can see that exactly what happens here. We're using dog and cat. We don't instantiate an object of type animal. Animal, that's not instantiatable, all right, if there is such a word. Okay? So that is, the example of an abstract class, right? Also, you can see that when we use the main method and we instantiate both Spot and Puff, right? Those two animals. They're both animal types, right? But they're different. They're a dog type and a cat a specific type. And notice we have this display animal method, right? Display animal. And display animal is not part of the animal superclass, all right? It's not. It's actually a static class that's part of our tester class, demo animals, which is like our program class. That's what it is, right? And what we do is we use the creature, whatever the creature is, which is of type animal, right? So we can pass in any animal into this method, right? Notice that we're passing in a method, or the method itself, it takes an animal type. Wait, we just said you can't instantiate an animal type. But remember, both the dog and the cat have an is-a relationship with animal. Animal, they're both animals, right? And this, my friends, is the power of using abstract classes. You don't know what type of animal that you want to use. Maybe it's going to be the dog. Maybe it's going to be the cat class. You have no idea which one, right? But you know that one of these two cats, or one of these two animals, dog or cat, as an example, is the thing that this method takes. One. You don't know which one. And because both methods are both classes are very similar in construction, we know that they both have a speak method, right? Then when we use the display animal method, the creature, and this is the name of the parameter now, the local variable, creature.name, creature could be either dog or cat. Both of them have a name, and both of them have a speak method. So this console write line works. Okay. So how does this relate to our little example? So I'm going to go back to my code now, right? So I'm going to go to VS 2019. And remember, we have this game object superclass. Game object, I've never made, or in my program.cs class, I don't use game object. I use player, I use red enemy, right? And I use boss. Boss, enemy, and player. Those are the three things I use. But I don't use game object. Why? It's too generic. I wouldn't make an object of type game object ever. So this is a good candidate, game object. This is a good candidate to mark as an abstract class, right? So we can convert a concrete class, because right now this is a concrete class because we haven't marked it as abstract, right? I can convert a concrete class to an abstract class. All right, let's do that. So let's go to game object here and just type the word abstract. Okay? And once we do this, I make this class abstract. It can no longer be instantiated as objects can't be instantiated as concrete objects anymore. Okay, that's the number one thing. Next, that's the first thing that we do. Next, notice that there are some things here, all right, that we can change. For example, we have this public string, toString method, and we have name and health and whatever, right? This is neat. But it would be nice if we had some kind of function, as an example, that we would override, like a method that we would override later on, and that we can have some methods like this, right? For example, we have the initialize method, right? We have the initialize method, but maybe, right? Maybe instead of just calling the initialize method, and we don't know, I mean, it's going to initialize different things. In this case, this transform, as an example, is being initialized. So we put our initialization stuff in the initialize method, right? That's what's happening right here. But wouldn't it be nice if we had something like a start method, something that we can initialize there, right? So instead of us having an initialize method here that, and then notice that we also have an initialize method in my enemy class. Here's my enemy class. Look, we could have an initialize method here. I could initialize stuff here. In my boss enemy, right, we could have some kind of initializer here, and we definitely have it in our player class. In our player class, there is an initialize method here, right, where I initialize my shield level. Okay. So it'd be nice if I had some kind of initializer method that you had to override, right, all the time. as an example. And the initialize or abstract methods could be both private and public. Okay, doesn't matter which one. But both classes, all the classes would have them. The other thing that would be something that we could define, right? Because we can say all game objects, no matter what they are, have a start method, and they also have an update method, right? Because I want to update their position or whatever, right? So let's do that. So let's say that I'm looking at game object here, and I'm adding two public methods. So there's a public method, it returns void, and it's going to be called update. Okay. But instead of me, suggesting that this method here is going to have a definition, I don't need to make a definition for here. I just need to mark this as abstract, right? So remember, just like in the PowerPoint, when we mark a method as abstract, so just going up here to the class definition, right? First you have the accessor, public, private. Then you have, is it abstract or concrete? If you leave abstract out, it's concrete. There is no concrete keyword, okay? And then the type it returns, and then the name of the method, and then semicolon. There is no implementation details, right? So just like this, we're going to do the same thing. We're going to say public abstract update, right? If I save this now, and if I go into my enemy superclass, notice that I have a little squiggly. It's different than virtual. Virtual is you may override, right? May, if you want to, you can. Abstract, you must override. Okay, so anytime, any method I mark abstract, you must override. I must include that in here. So in my public methods, I need to, by the way, there's two ways of doing that. You can go here, and if you're using ReSharper, and if I hover over the this little light bulb here, as an example, it'll say implement missing members. It's a missing member because we've marked it as abstract. Okay? And now you can see that I'm publicly overriding our update function. Okay? Notice it also subs in a not implemented exception. We're talking about exception handling later. So this is our update method. You can actually leave it empty as long as you define it. It satisfies the requirements of the enemy of the superclass game object. Game object is an abstract class, and because game object defines update as abstract, so we can call them public abstract methods. We can actually define this here as a comment. These are our public abstract methods. I can have another one too. Like I said, I can have one that's called start. Okay? So I can have a start and an update. I can have another one called reset. Maybe I want to reset stuff all the time. So start, update, and reset. And they do different things for different classes, right? Different subclasses will handle these methods differently, but all classes will have start, update, and reset. Every class that's derived from the game object superclass are going to have these methods, right? And they must have them. I'm forcing every other class that's derived to have them. Not like this. This is may override. These must be overridden, right? And I'll say must be overridden. Okay? No choice. Once you mark them as abstract, they have to be overridden. They have to be made, right? And again, look, I made the start method or the update method in my enemy, but now I got a problem again because even though I made this one, I still have two more methods to make. So now it errors out again. So if I go here and it says implement missing members, you can see now what it's going to do is going to give me a little dialog box that says, do you want to implement start and reset? And we'll say yes. And so it creates all of them. It'll create a start, update, and reset. And notice it puts them in the right order. Start, update, and reset. That is, it doesn't have to be this way, but typically this is good. And now that we have this, start, update, and reset, we can give specific details for each of these things. For example, I always want my start method to be called in the constructor function. So I can do that. I can say start whenever the constructor function starts, it calls the start method, right? And the start method, I can do some initialization, okay? Or some other things, and that's what I would use the start method for. Updates I can, once I call update, something happens. Maybe my position changes or whatever, right? Every time I call update, okay? And the reset method, maybe what it'll do is it'll reset certain things, like it'll reset the health of my enemy. Because remember, my enemy, because it's a game object, right? All game objects have a health value. All game objects, right? Even though I haven't really overridden it, I may override the health value. I may if I want to. If I don't want to, I can leave it as this, and this is how the health property will work, okay? So that's enemy. Enemy is taken care of now. Now, because even though they're empty, because I've defined them, I satisfy my requirements, okay? They can be empty, and it's okay. But boss enemy is not good. It's not good, right? Because, well, it is because enemy doesn't force you to, because boss enemy derives from enemy, and both can be defined. I can define both an enemy, a regular enemy, plus a boss enemy. There's different types. One is more specialized than the other one, but I'm probably gonna kind of instantiate both. Even though enemy is a little bit abstract, I could mark it as abstract. And if I do mark enemy as abstract, as an example, right? If I mark enemy as abstract, what's going to happen is then I must override something here in my boss enemy. And I should, right? I should be able to implement them. And if I hover over this as an example for enemy, because not all enemies are going to, not all boss enemies are going to update the same way, right? It doesn't make any sense. Maybe my my update function needs to be slightly different from my boss enemy than it is for my regular enemies. So the way we have it laid out, both the enemy and the boss enemy, because they're the same, there is no update method or anything else in here, right? I don't have to override anything. It's may override. Okay, I'm going to come back to this in a second. Player, though, right? Player's got a problem because player derives directly from game object, right? So I must implement it, and it tells you which ones aren't implemented. If I hover over, it says these abstract inherited members, start, update, and reset must be implemented in order for this class to pass its requirements. So now let's make that happen. So I'm just going to implement those classes, those methods. So if I go down here, you can see now they've been implemented, right? So, and they've been implemented here. Okay, I'm going to pull these down where I want them. You can move these around. Like I said, it doesn't have to be in a specific place. I have lower shields I never use. I want to make this other area down here, which are public, methods, overridden methods, right? These are the ones that have been overridden, right? Because I've got that override. And I can make them empty again, not a problem, and it would satisfy the requirements. Okay, because these are the start, update, and reset. I must define them differently than in the other ones. Okay. Again, chances are what I want is my start method to be called by my constructor function. So in my constructor function, which is down here, right, I have an initialize method, right? And then now I can think about that the initialize method itself, even though it's private, I could use the start method instead, and it makes more sense to do that. So I'm going to call this start. I'm going to actually override. I'm going to do something here. And I'm going to take this part out here just to revamp this class a little bit so it adheres to the idea, right? I'll do my shield. So start, this will be a new lifecycle function. Start, update, and reset. There'll be 3 new lifecycle functions. And start will do all my initialization. I don't have to use m_initialize anymore. So I can get rid of this. Because it doesn't adhere to the same ideal, right? I mean, sure, does it have to be public, my start method? I'm going to make it public. So I can always call start and it'll always initialize here or whatever. But we have a problem. Our problem is this boss enemy idea. Boss enemy is deriving from enemy, and sure, it has an overridden fire bullet method, right? But it might make sense for me to make different kinds of enemy. So instead of making my enemy superclass, right, my enemy superclass might have a fire bullet method that I want to override, right? So right now my fire bullet method is virtual. You may override this one, or you can accept all bosses do just at least this, right, as an example. But they also have this start, update, and reset method, and these must be overridden. They must be overridden. So there's two things I have to change. Either I make my my boss enemy derive directly from game object, or if I make my boss enemy derive from enemy, I've got to think about a way of passing these, these methods there as well, right? I can't do public abstract override start, right? I can't do that. I can't go public abstract override start. That's just not going to work, right? You can't do both override locally plus abstract for the things that inherit. You can't do that, okay? If I do this also, because my method is abstract as an example, right? It's abstract in the game object superclass, right up here. I've made it abstract. If I make it abstract, right, and if you notice in the enemy class, it tells me that enemy start cannot declare a body because it marks as abstract, and it says enemy.start is abstract but is contained in a non-abstract class enemy, right? So that's another thing. If I was, the only way I could do this is if I mark this class as abstract, which means I can never instantiate an object of type enemy. Let me show you this one. So if I did this abstract, right, would it take care of this? Well, it says abstract can't have a body. Okay, how about this? It says it cannot declare a body because it's marked abstract. Hides inherited abstract member game object does start. So I kind of override it, right? If I take this away, I'm just going to show you this. If I take this away and I put a semicolon, right? So it satisfies requirements, but then because my superclass is abstract, right? It says, here are the two errors now. It says hides inherited abstract member game object start, and then it hides inherited member this to make the current member override that implementation. Add the override keyword, otherwise add the new keyword. Okay, so this is interesting. I could use new, right? So a new public abstract, class. I can't do abstract override, right? So this is something I can't do, typically, all right? Now this is interesting. If I did this public abstract override and no implementation, right? No implementation, this works. So basically what it does is the override and the abstract keyword working together, it bypasses this class. So this class cannot have a implementation in here at all. But what it does is it forces the boss enemy to do it, because boss enemy also inherits from the class, right? So if I go implement the missing members, you can see here that I must override the start method here in my boss enemy. Okay. So that's one thing I could do. The other way I could do it, I'm just going to undo this. Okay, this one option for this. So yes, I can mark it as abstract, right? I can mark it as abstract, but abstract classes can also have virtual methods that you may override. You may override. And that might be another option for us, right? Okay, another option. So let's make this not abstract for a second. Remember, only abstract classes right now can have a, I'm sorry, so make this not abstract. It can use the abstract keyword, okay? But how about this? Can I make this virtual? Can I go like public virtual override and then define a, a method like this, right? So public virtual override. And this says that the override method cannot be marked as virtual, right? Why? Because I'm overriding it, and I can't do both. I can't do virtual and override, right? And if I switch these around, if I said override, and I make this virtual, so I want it to be overwritten again by my other class, I can't, right? However, the effect, if I just said override here, like this, if I wanted my boss enemy to also have these and have an override, let's see if that's possible. So let's say, for example, I want to take these three methods, right? My boss enemy, I want them to have it, and by manually, I just want to put them in. Oops, put them in like this. Is that allowed? And if you notice, even though I don't have to do it because my enemy does it for me, I could do it just like I would with the toString method. Okay, so these are, again, public overridden methods. May override, right? Whereas the other one, enemy, right? These ones must override. Right? Why? Because enemy derives directly from GameObject, whereas boss enemy is indirectly related to GameObject, and so they only may override these things. Okay? So that's the difference. I know it can be a little bit confusing, and you're going to say, so why abstract classes? Why would I do this kind of stuff? Because from a context perspective, that's one reason that you'd want to do it, right? And remember, because all game objects have a start, update, and reset method, I could call the update method, somewhere else. Like, for example, I don't know, GameObject.update, right? And whatever the game object is. And that would update any one of these game objects, not just a specific type. So player, as an example, I have the start method. I do some initialization, my shield level. And my boss enemy, I can do some initialization right now. Remember that the boss enemy also has health, right? Because they both derive, all three of them, enemy, boss enemy, and player, all derive from the GameObject superclass. So they all have a health value, and they all have this health. So I could kind of set up a health value for, enemy, boss enemy, and player. So let's say, for example, the boss enemy in my start method, which I'm going to call from my boss enemy's constructor. Let's call this start method, right? And by the way, notice that I'm calling the start method from the constructor every time. So start here, I called start here, and I called start here. Okay. If that's true, if I do that in every one of these classes, then it makes sense for me to do that here in my GameObject superclass, because I'm already doing it, right? So what I could do is I could say, hey, let's call initialize. That's a private initializer for my GameObject superclass. But after the initialization is done, let's call the start method too. Even though the start method here doesn't have any kind of body, that means every class will call the start method. Every subclass will call its start method automatically, which means now, and I got to say this, when the GameObject constructor is called, because the GameObject's constructor needs to be satisfied, it's going to call the start method automatically. And to show you this, I can not do this anymore. I don't need to do this anymore because I'm already doing it in my superclass. I'm going to show you this for a second. And let's just do a console write line in each one of these things. So in my enemy's start method, I'll say console write line. We'll just say start method, so we know we're here. Okay, and I'll copy this a couple times so we can do it in the other ones. And let's also talk about the type. One thing we can do is we can also say I want to interpolate the type. So I can say I want to use the GetType method. Right? GetType is part of the object super duper class, and that's actually in your notes, right? So I can say I want to get type, and I can pass in the type that I want to get. If I hover over GetType, it says whatever the object is, get type, object get type, right? Well, I want to get this type, right? I want to get type of this object, right? Notice that this is implied, right? So if I say GetType, I want to get the type of this, whatever the type is. So this type is enemy, an enemy start method. So I want to get this, copy it, and again I can go to the boss enemy and put that in the start method. GetType also works for boss because GetType is the super duper object type. Object member is the super class for all other classes, and it has a GetType method. Okay, and the same thing goes with the player. In the player, when I go to the update and to the start method, I'll also call the start method here. Okay. So now we haven't changed much. Okay, nothing as much has changed. I mean, really, I'm just saying this. In my boss enemy, let's just make sure to make some changes. So in my start function, I can say something like that health, right? Let's say the health is equal to 200 for the bosses. Bosses have 200 health, whereas player and enemy only have 100 health. And if you really want to make a stark difference, you can also say that enemies, they're weaker than players, they only have 50 health starting off. So we can say all enemies have only 50 health. So health is equal to 50. Okay? So that's a difference, right? All right, let's run this thing and see what we get. So if we do this, and if everything goes well, and nothing crashes, right? Let's see what we got here. We got, okay, so we have our player. He's got 100 health, right? And it says, listen, look at this. COMP123, M2020, Lesson 5, Part 1, Enemy. This is the type right here. This is the type. This is the type, right? Why? Why do we have this other part here, which is this big part right here? This is a namespace qualifier, right? That notice all of them have, okay? And you can see that the boss enemy start method was called, the enemy start method was called, and the player start method was called. And I didn't have to put these starts inside of their own constructors because the constructor of the GameObject superclass is being called first. And I'll talk about that in one sec. Notice that the health value of the enemy, the red enemy, is 50, and that the boss enemy is 200, right? And that got updated in the start method. So you can see that the start method has been implemented differently, right, in each of the objects: enemy, boss enemy, and player. Okay, so more specialization. So questions around this so far? Any questions around how this works? So let's go back to the diagram then, just to make sure we understand. So again, if student was an abstract class, and then I have some method, for example, I have a method like, or a property, international address, I have a domestic address, you know, there's some differences between the two different types of students. Maybe, you know, domestic students have access to local funding, but you know, international students don't, let's just say. And there's many other little things that are different between one student and the other, right, as an example. But all students have a name and an age, right? And maybe what I can do is I can, when I set up a all students, maybe when I create the student ID is made here at the student level, right? And maybe the student ID is made up of some kind of combination of the student's name, as an example, and their age, and the year. Let's just say some kind of, you know, wacky combination like that, right? Well, it doesn't matter what student it is, international student or domestic student. The student ID will be common to both in terms of the way it's made, right? So this is where it'd be a good place for me to house that kind of calculation. If I was going to make a calculation that affects both types of classes, right? All right. Okay, so what's the difference between overload and override? All right, that's a good question. That's a really good question, actually. So when I want to overload a constructor or overload a method, I create multiple signatures for those methods or the constructor. And what I mean by that is in the same constructor, so let's go back to code, all right? Right now, again, in my GameObject superclass, right, we only have one constructor called GameObject. Here's our constructor called GameObject, right? I could have another constructor called GameObject. Let's make another one, okay? And I can make this one, I'll make it up here. I'll make this one the default constructor, right? So I can say public GameObject, right? I could do this too, right? Public GameObject, this is another constructor, but this constructor has the default constructor signature with no parameters. These two constructors are set to be, or this constructor is set to be overloaded. Why? Because I have one method signature here and another method signature here with the same name. That's an overload, okay? It works the same way for methods, method overloads, as an example. And we did this method overload stuff when it came to the vector 2D class. Our vector 2D class, right? What we're actually doing is making a method overloaded operator is what these are called, right? These are different kinds of overloads. Operator overloads are different than method overloads. However, we made an overloaded operator that has two different types of multipliers, right? I can multiply a vector by another vector. I can also multiply a vector by a scalar, right? These are overloads, right? Override is when you want to change the method. You want to give the option for the derived class to change the method implementation, the stuff between here. Okay? Overload changes the stuff up here. Override changes the stuff in here. Okay? That's the difference. Does that make sense? Okay. I know it's a lot. It's these words, override, overload, and people get confused. But the reality is every object-oriented language has the same methodology. Doesn't matter if it's JavaScript or like Python or C++ or Java. Any object-oriented language has that capability. All right, so that's important to understand how to do this. All right, we also have a thing that I've done where I've said, as an example, that a game object needs a name. And the problem with identifying a game object with a name is that if I put the wrong name in here, as an example, or the wrong string value, let's say, for example, I need to identify, I do some kind of switch case, right, in the program class. So in the program class, I'm saying, hey, let's do a switch case, and depending on it is if the player is a player, or the game object is a player, or if the game object is whatever it is, right, I want to do something. Let me show you what I'm talking about here. So let's say I do a switch case, okay? And I want to switch on the type that I'm getting in, okay? So let's say, for example, I want to switch on game object type. So I want to say, or game object, and the game object is going to be something that I update, okay? So I want to update something. I don't know what I'm going to update as an example, but I'm going to update one of the objects, one of the game objects, okay? I don't know which one yet, okay? So example, let's say I made a public static class, public static method, all right? So we'll make it up here, all right? So under the program superclass, right? It's called program. Let's make a public static. Actually, we'll call it just static. A static method, all right? We'll call this update, okay? Which returns void. We'll make this void, okay? How about we do it right? Public update. That returns void, right? There you go. Yay. Okay, so public method, a static method called update, right? That returns void, okay? And we're going to call this static method down here. We'll just call this update, okay? And I want to update each of the objects, right? So I want to say, depending on the objects that exist, let's say, depending on those objects. And by the way, let's let's make it a little bit more complex here again. In the program, we'll make a static list, okay, a static list of type GameObject. So a GameObject list, all right, static list of type GameObject, okay? And the static list of type GameObjects, we're going to call this GameObjects, okay? A static list of type GameObject called GameObjects, okay? And inside the main function, I'm going to construct it. I'm going to say that GameObjects is equal to a new list of type GameObjects. You need to do this because what this does, it creates an empty container, right, for the GameObjects. So when I do this, if I want to make a list of GameObjects, right, think about this as an array. It's a collection type. So I don't know if you guys have seen list before, but list is the name of the collection, and the type is you put in angle brackets in here, right? So a list of GameObjects, like an array of GameObjects. That's what it's like, okay? So a list of GameObjects. In order for me to do this, I need to instantiate the empty container first with a new keyword, okay? And what I want to do is when I instantiate a new object, like with the new keyword here, new player, new enemy, new boss enemy, I want to add these three things to the list, to the GameObjects list. So as soon as I add it, as soon as I create it, I add it to the list. So I can do something like this. I can say that my GameObjects, right? I want to add, right? That's the verb, and the type I need is a GameObject, player. Okay, so I added the player to the list of GameObjects. Okay, cool. I like that. That's a nice idea. Let's do the same thing for the red enemy. So when I instantiate a new red enemy, I want to add the red enemy to the list. Right? And I want to do the same thing with the boss enemy. So, oops. So I want to grab this, and I want to add the boss enemy, this boss, right, to the list. Okay? So I have player added to the list, right? So what does that list mean? Okay, first of all, if I was going to draw the list of GameObjects, let's just draw it out here, just so everyone understands. Again, I'm going to assume, for example, you've forgotten what a list is, or you've never been taught something like that, or you don't know what an array is. But let's suppose I have this is a list, right? And we'll say that this is a list of type GameObject. Notice I didn't say a list of students, or a list of persons, or a list of whatever. It's I can make whatever list type I want. I could make a specific type of list. For example, if I was going to make a list of person list, in this case, this is the person example, so let's do the person list. Here it is. I could include a student. I could include, student would be an abstract type, right? An abstract type. But a domestic student, an international student, and a professor would all be person classes because they derive from the person superclass, right? So if I was going to instantiate, some objects, let's say, for example, I instantiate an object of type professor, and I call this object, so I'll say professor, we'll say Tom is equal to a new professor, right? Let's say I did this. So I did this for Tom. So that's the object. This object here has been created from the professor concrete class. And let's do some other ones. Let's do international student and domestic student. Let's call Jose, all right, is a new international student. International student. We'll call him Jose, and he is a new international student. I'm just making this up, guys. Please, hopefully, I'm just doing this as an example. So hopefully, you guys are good with this. I'm not, kind of targeting specific names. Okay. Look, I even used lowercase Tom for T and uppercase J. I'm not really, this isn't a planned thing. And the same thing goes with domestic student. So domestic student. Let's just say I make a new student. We'll call him John, right? And John is a new domestic student, but John is also a name that can be used internationally as well, and often is. All right, so there's the kind of a domestic student, John. So, but I want to form a list of persons, and I can say that Tom is in that list, Jose is in that list, and John is also in that list, right? Because each of them has an is-a relationship to the person superclass, right? Even though John is a student, and so is Jose. Jose is a student, right? But both John and Jose are also a person. So therefore, this works. Okay? So this is the thing I'm going to try and do now with my game objects. Let's go back to the game object. So I've made those. I've said that player is a game object, right? And both red enemy and boss are both game objects, right? So now I have a list. In my list, I have those three objects: player, red enemy, and boss. And I've put them, whenever they get instantiated, I add them to the list. Okay? So now that I have that, in my update function, I can say that I want to update each of the objects that are inside of the list called game objects. So I can say that, let's update them all. So I'm going to say for each, right? And if I do tab, it says for each, the collection that I'm targeting, which is game objects. Here's my collection. And then the variable name, this variable name here is the variable. Notice this is var. I'll talk about that in a second. But the variable is going to be called game object, lowercase, and only single. Game object. So for every game object in game objects, for every one, and we can make this a game object type if you want to specify. The var keyword, if you haven't learned what that is, says, oops, it says, hey, I don't know what type it is. That's what var means in C#, right? I don't know what type this is. Can you figure it out? And what C# will do is use something called type inference, right? Type inference to figure out this type. And if I hover over the var keyword, it actually figured out that game object should be a game object type. I could call this, by the way, anything I want. I can call this, like, Tom, right? And automatically it knows that Tom is a game object, right? For every Tom in game objects, right? It doesn't make any sense. But so you call it something reasonable. You could say GO for every game object in game objects. Some people do that. I don't like GO because GO is very, kind of short form. So I like calling it game object, lowercase g, single. Game objects, lowercase g, plural. For every game object in game objects, that's how I see it. And I can specify if I want to be there. If I want to do that, I can say game object. I could do this. This is a fully qualified variable type, or explicitly typed. That's what this is. Or if I don't know the type, sometimes I just put var. For every game object in game objects, I want to call the update function, right? So I want to say that game object dot update. I can do that because each game object that I've created has an update function. Every one of them. Okay, that's what I'm going to do. I'm going to do this once. I'm going to go through the list, and I'm going to update each of the game objects. Okay, and let's just make it so that each of the objects gets updated. So I'm going to go into my enemy class, and we'll have another write line. It doesn't do anything right now, but we'll just make it a stub. And we'll say this type got updated. Okay. And we'll say that the same thing happens for our boss enemy as well as our player. Okay, so that each one of those gets updated. If I was to do this, and in my program class, so I'm going to call the update method in my program class, I call it down here, this update method calls this static update method, which calls the update method of each of the game objects for each game object in the list that I created. Let's go back. I created a list, added each of the objects, 1, 2, 3, right? Each of these objects were added to the list, just like I showed you. And then I updated each of the objects in the list by using a for each loop. So for each loop again, access each object in the collection, right, is what this does. For each object, for each game object in game objects, do the update method. That's what it does. It calls the update method in this case. All right, let's see how that works. Does it work? Cool, look. Player is updated, enemy was updated, boss enemy was updated. Nothing happened. We didn't do any kind of update, but we just kind of outputted we did an output here. Okay. You know, it's a great place to put it up on GitHub because I've added an update method and I've made my game objects abstract. So let's do that. So I'm going to go Team Explorer. These are all the things I changed. I'm going to say that you know, converted game object to abstract. Say. We can also say marked. Mark game object as abstract. We marked it as abstract. Commit all. And then we did other things too. We could have had many more commits here. Home, sync, and push. Okay, and now you have this update up on our a GitHub repo. So if you can follow along, you can always go to my GitHub repo and look at the program CS class, and you can see what this is. So this is cool. I want to update everything, but what if I want to check to see what the name, depending on if the names for each object in game objects, when I go through and I check the game object name, if the game object, as an example, is called player, then I want to do something. Okay, so I can say that, hey, if game object dot name, right, is equal to player, right, and then I want to say accessing player class. Okay, but there's a problem with this. There's a big problem with this. I have to remember the name of my player, right? I have to remember the name of my player, the name of my object. What if I had many objects? Instead of having only 3, I had 50, 100, 200, 500, right? Trying to remember the name of my player class would be terrible. It'd be really hard to understand this. So what's a better way to do this? Instead of making a name, if I want to access the name of the player, the name of the object, what's a better way? You guys already know it. It's an assignment too. What's a better way? Instead of having a string variable, string value, there's a better way of doing this. Guys, think about this. So example, I have player, and then I have another one. By the way, this is wrong. And I might say else if, or I could do a switch case. So I can say, let's do a switch now instead of this, accessing the player class. Let's do a switch. And the switch case is going to be on my game object dot name. All right. And I can say case player, do something. Case enemy, do something else. Case boss, do something else. Okay, and all these are going to fail, by the way, right? And I can say that we can say that you know, player was accessed. Okay, because I'm accessing the player in order for me to update it. I'm making this up here, okay? But I want to do the same thing with my boss and my enemy. So here's my enemy. And we'll say specifically red enemy. So red enemy was accessed. We'll call this red enemy. And this one would be just boss. Okay? Are any of these going to pass right now? Well, the answer is no. None of them are going to pass. Maybe one of them will. Let's take a look. Enemy, when I created an enemy, right? In my constructor function, I have to specify a name. Well, that name has been specified in the program. And if I look at the program file here, my program class, I made it my name red enemy. So this one might be okay, red enemy, right? Because guess what? I'm searching for red enemy, but look what my case is, red enemy. This is wrong. Look, I didn't make it right. Why? I couldn't remember. I couldn't remember what this is, right? And what about my player? Did I get that one right? I know that the thing is called player, but player even doesn't take anything in. Well, where does that happen? That happens inside the player constructor. And the player is right. Player is capital P, so that's going to work. Okay, no problem. Nice, nice. What about boss enemy? Well, boss enemy is just boss. I specified it here, so that's going to work, right? So boss looks like I did that right, but enemy, I did wrong. And what if I had, again, 10 more, 50 more, 100 more? It doesn't make sense, right? So a lot of times what we do, instead of having a name that's a string, we use an enum, which is part of your assignment too. So let's use an enum instead of a string. Let's change the game object. We're going to make some breaking changes here. I'm going to change the name value, this name, instead of a string, I'm going to make an enum. And I'm going to make an enum in a separate file. Right? So again, I'm going to go here. I'm going to right click. I'm going to add a new item. Notice in the items, when you're adding an enum, do you see an enum option here? Is there? Right? There isn't. So I go to my class, and we'll call this, right? We'll call this the game object type instead of the name. Game object type is the new enum. I'm going to click add. And instead of a class, we'll change this to enum. All right, enum. And the enum is going to be called game object type. Okay. There's my game object type. That's the enum. Okay, I need some types. One will be called player. The next one will be called red enemy. Usually what we do is with enum statics, we use uppercase characters like this. And the last one will be called boss. Okay, those are the three types. So player, red enemy, and boss. And what's this? Did I do something wrong? I did. I forgot to. I killed one of my braces. There we go. All right, does this make sense? So this is I think the other thing is this. Do I need to put public in here? Yeah, because if I don't put public and I make this a regular enum, that's bad. All right, so public enum, player, red enemy, and boss. If you ever hover over the enums, it says 0. That's the value of the player. That's the value of the enemy. That's the value of the boss. And let's make one more. We'll say number. This is a trick, by the way, of game objects. Why do I want this? If I want to know the number of different game object types, okay, number of game object types, right? Why? If I do this one, this is 0, this is 1, this is 2, and I want to know how many. I hover over this one, I have 3. If I add another one, here, let's add another one, bullet. That's a big game object type, right? Then now I have 4, right? But these ones are 1, 0, 1, 2, 3. I don't have a bullet yet, but I added it in ahead of time. Cool, so I have these 3, and if you hover over this, it says name player does not match the rule enum member, suggested player lowercase. One thing you can do with this is you can modify your naming conventions. So it says that inconsistent naming, disable once, comment, configure inspection severity. This is all inside ReSharper. This is a really cool tool you can use, right? And you can configure it so that I want to make sure that it says make this player to the abbreviation list. Change naming rule for enum members. Look, right here. Change naming rule for enum. I want to change that. So now what I want to say is that all enum members, as an example, are all uppercase like this, right? That's what I want to make all enum members. And you can get this from, again, ReSharper. Look at that. It says, see that little symbol here? ReSharper, C# tells us that this is the way it is. If I press save, now it doesn't give me that linting anymore. It doesn't say there might be an issue because I've named everything properly. Again, this is a little thing. It doesn't really matter. It would work the other way too, but this one gives me some code hinting that things aren't done right. Okay, so now that I have an enum, game object type, I want to use it. right? Game object is going to use game object type, but I'm going to make some breaking changes here. Let me show you this. So again, game object, instead of a name that's a string, let's change this name to this type to game object type. Game object type. Yay! Oh boy, here's some breaking changes. So now a name is the type. Let's rename this thing. We're not going to call it name. We're going to rename this thing to type. Refactor rename. We'll call this m_type. So type. Yep. There's type. And the type is not going to be string. It's going to be game object type. So this satisfies my requirements because I've gone down and said type. And then when I go to my constructor, this is wrong because string type, that can't work. It's got to be game object type. I'm modifying this now. So now whatever the type is, that's equal to type. Type is equal to this. Makes sense, right? We're all good. So far, no more errors inside of my thing. Here, this is wrong. Output string is equal to name type. This should be type, whatever the class is. And I want to convert this, the name, the type, which is a game object type, right? It's an enum. I want to convert it to a string. So again, if you look that up, and I want to convert the name. So convert enum to string. And if we look at C#, which is where we want to do the conversion, right? There is a special way of doing it. It says the following code example shows this. And this is important to understand what you want to convert. So you notice that the weekdays in enum, Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, but they're 0, 1, 2, 3, or whatever. And I want to convert them, right? So here it is. Look, take a look at this. Enum, get names, type of, and whatever it is. Enum, get names. And what does it print? We're hoping that it prints out, Monday, Tuesday, Wednesday, Thursday, Friday. So get names. Let's see what that does. So that's a hint of how it can work. So again, I want to get names, whatever the enum is. So if we want to say game object type dot, actually it's an enum class, enum dot get name, and we want to pass in the enum type, right? So that's what it needs, the type name, which is the game object type, right? And what it also needs, not just the game object type, but which is the type that we want. In this particular case, it's called type. Let's say we want get name of this type, right? And it says it has it has 2 parameters, but it's invoked by 1, right? Because get name has 2 parts, the enum type and the value, right? Object. So we're not quite satisfying the requirements of this thing, right? And by the way, whenever we use get name, remember that get name dot, there is no, if I open this up, you can see that it has, there's get type, but we want enum get name. Get name. If I do enum get names and I put in the type, right, as an example, it's just going to retrieve an array of names, right? I want a specific name for the type, which is the type that I want. Type. Okay, that's the one I want. But I also need another thing, which is the value. So whatever the output is that I want to output. So now this is the thing that I want to return, right? So where I'm returning the output to, the output string. Okay, so let's take a look at a better example, because that's not a really great example of how to do that. So weekday as an example, weekday, which is enum is 0, and then weekday toString. Weekday toString. So notice that weekday is equal weekday.friday, weekday.friday, right? That's the type, weekday.friday, and we want to do weekday toString, and that should return everything we want. This is the one way to do it. Okay, let's try this out again and say maybe that's another way of doing it. So we say that I'm going to convert this. We're going to say that our type dot toString, and maybe that's going to do it for us. So toString converts this type to a string. Let's see what that does for us. Maybe it's going to work, maybe it won't. Maybe we'll have to use that get names thing that we talked about before. All right, so toString. I don't want the number, I want the name, right? So we'll see this in a second, what it does. All right, so okay, cool. Look at all these ones. They just all changed, right? So game object changed because I'm taking a type now and not a name. Oh boy, oh boy. Let's go to enemy. Well, enemy now can't take a string. It's got to take a game object type. It's going to pass that in. Yay, that's satisfied. No other errors. Okay. And what about boss enemy? Boss enemy can't do this anymore. It's got to specify a type. So I can say that my type for boss enemy is boss. That's what I want. But I can't do this. I need to specify the qualified name, game object type boss. Right? So there's now, I can't select something by myself. I have to choose one of the options from the enum. Same thing with player. I can't just choose player anymore because that doesn't satisfy the requirements. It has to be game object type player, right? So that gives me a list of a pull down to select, which is a better way of doing things than me typing everything manually. If I go to my program.cs, also this doesn't make any sense because now my red enemy can't be like this. I have to call it red enemy. Game object type red enemy. The red enemy is the one I'm making from the game object type. These are all good. Good. Right? And then this doesn't work anymore because game object type is what I'm actually scrolling through, which means this one would be game object type player, and this one would be game object type red enemy. And this one would be game object type boss. Okay. And let's see what happens when we do a toString now. Let's see if we get that type, the name, in there as opposed to something else. Let's try this out. So, and let's see what we get. All right, it says type is player, type is boss, type is player. This is good. Type is red enemy. So this actually prints out the string. It's nice. We don't care about the value anymore, just the string when we do a toString. Okay, that's nice. And it tells us that the player was updated, the enemy was updated, the boss enemy was updated. These are all good things. And you can see that player was accessed, red enemy was accessed, boss was accessed. So we're able to do this selection by using the game object type. So this is a good use of an enum, right? Why? I can't make a finger typing error and type in the wrong string name, right? If I make the wrong string name, let's suppose I'm loading something. I want to load one of these things, and I put the wrong string name for the name of the thing I want to load. I'm going to get an error, right? As opposed to, especially if the loading function uses some kind of switch case to load a file, right? As opposed to me using an enum, and the enum itself will select the thing I need to load. Hopefully that helps. Okay, let's put this up on GitHub. So again, Team Explorer. I'm going to go to Home. I'm going to go to Changes. I'm going to say I'll added game object type enum and enumeration. Commit all, and we've made all those changes. Right? Commit all, Home, Sync, and Push. There you have. There's enums, or how to use enums with this, and it makes sense because now these make more sense. I can only make specific types of enemies or game objects as opposed to whatever game object I want. And that makes more sense because then I can identify the type by my game object type, red enemy, boss, player, right? And it's better than doing something that looks like this, which is I want to, if I go back to my enemy, right? I want to do GetType. I don't want to do GetType. I want to use my own type, which is here, right? So I can say type.toString, right? My type.toString. That would be better, right? So type.toString. I'm going to use the toString method of the enum, right? I want to use type. This is GetType, right? Type.toString. Okay, so that I can do that too. So this was this start method, right? Was updated, was accessed. You know, again, type firing bullet. Type dot toString. Okay, that makes more sense, right? Same thing with my boss enemy. Type dot toString. Right? Type dot toString. Type dot toString for my GetType. Right? Type dot toString was firing the bullet. Okay. I'll make those changes here too. Instead of GetType. GetType is a generic thing that's used by the object superclass. But this is more specific and it looks nicer. I don't have to have that fully qualified name anymore, right? So if I run this thing now, you can see that I'm going to get better feedback. Boss firing fat bullet. Boss start method. You know, player was updated. Player was accessed. Red enemy was updated. Red enemy was accessed. Oh, I missed one. Boss enemy was updated. Okay. That means in the boss enemy, I forgot to put that in. Type toString. Yeah, there it is right here. All right. Isn't that nicer? Right? It looks nicer and it's more descriptive for the user. So whenever you make a class for someone else to use, you want to use enums wherever you can. All right, so we covered a bunch of stuff today so far, and we covered what abstract classes are at a very high level. Abstract classes are not concrete. You cannot instantiate types of type thing. Now, one thing we talked about before was this idea of multiple inheritance. Someone asked me actually in the first day when we started covering inheritance on week 4, hey Tom, can we have a mother and a father, 2 parents? And the answer is not in C#. C# is a single inheritance language, which means you can only have one superclass. However, what we can use instead of multiple inheritance is interfaces. And now this is where things get crazy. I'm going to cover interfaces again in the next lesson. So I'm going to go over it one more time, almost like as an addendum to this thing, because they're so challenging sometimes to wrap your mind around. So it's like I want to have, why would I want to make multiple inheritance anyway? If I was going to do multiple inheritance, and let's just do this in our diagram. So let's suppose I wanted this child class, this domestic student and international student. Instead of it being a, these concrete classes as an example, and I wanted them to have something else, some other thing. Like, let's say a student that had a loan, right? Both students can have a loan, right? And it doesn't matter whether you're a domestic student or an international student. And it's going to have the same method, I might have a method that's like, get loan. That might be the method, right? To go to school, as an example, right? So I can't do a multiple inheritance. I can't say like, I want them to also inherit from the loan class, because now we're going to have that multiple inheritance thing in C#, and that's not allowed, right? However, and it's for type safety like we talked about before. However, what you could have is this interface. It's an interface. It's outside of this method here, outside of this this chain, right? And this is an interface. Typically, when we name interfaces, we use an I in front of it for interface. So we specify it's an interface, I, right? And then the name of the interface. For example, the has loan interface, right? So has loan. Okay. Let's say the loan is like way of getting money, right? As an example. Or I could instead of money, I can say each one of these students has credits. So we can say credits like from courses, or courses, whatever it is, has courses. Both has courses. The domestic student has courses, and so does the international student. They also has courses, right? So we'll make it courses instead of credits. Courses. There we go. And the I has courses interface is like a contract. It says that, hey, you know what? Any class that inherits from my I has courses interface must override a method or some other kind of values in here for both these two classes. So example, these two classes, if they inherit from I has courses, maybe I'll have a course list course method, right? So I'll say the maybe we'll have a method that is a abstract method, right? It's like an abstract method, but it must be overridden, and it's got to be public. So it's like this method returns a course list. Let's say for the method it returns a list of courses, right? And the method's called getCourses. Okay, that's what the method name. Notice I didn't put public in here. Okay, I didn't put public. Okay, so this method is part of the iHasCourses interface. This is an interface, right? And now what we can do is not only does the child derive from abstract student, but we say that it implements, this is the new thing, it implements the iHasCourses interface. Implements. So it's like a dotted line. You make kind of a dotted line like this. And not it doesn't have to be crooked like I made it, all right? By the way, I'm just gonna make it like this. So these kind of things are saying that it's not multiple inheritance. It just has one method or multiple methods that are in the iHasCourses interface. So if I go back to that, that's the first thing. The first thing is like, it's an alternate way of doing multiple inheritance. It's not ultimate inherit, but what it does is it has a method definitions you must override. So here's an example. We call this thing iWorkable, right? So notice there's no public or private. It must be public, so you can't change the access specifier here at all. And it has a method, work, okay? And what we can say is that the employee is, it implements, even though the colon is usually for classes, we can also say that the colon, when it comes to something that's an interface, implements that interface. Whereas if it was a class, it would extend that class. Okay, so let's put that down as well for words. So we extend classes, we implement interfaces. Okay, so different words, they mean different things. Okay, so that's what we do. We extend classes, but we implement interfaces. Okay, we don't extend interfaces typically. Okay, so notice that both the employee and the class animal implement the iWorkable interface, which means they must have a work function, a work method here, and there's another one down here. You just can't see, it's been cut off. Okay, and they must do it. They must have it, even if it's empty inside. Again, here it is. Here's the animal. The animal, notice it says that the dog derives from animal and overrides the work method. I watch the house. That's the dog's work method. The cat method, right, which overrides the animal, right, extends animal, overrides the work method. Both of them have two work methods, but a cat catches mice and a dog guards the house. These two methods, the work method, is being forced. I'm forcing the derived classes to have this method when I make a let's go back up here. When I'm making almost like a deal. I'm making a contract. Okay, so here's my dog and my cat, and as I go down into this interface, once I do this and I implement my iWorkable interface, the classes that implement the interface, right, they must override the method that's included in the interface. So it's like I'm inheriting from two abstract classes. That's what it's like. But I'm not really inheriting, I'm just implementing. Okay? I can implement multiple interfaces. I can have iWorkable, iDrawable, iUpdatable, whatever. You know, there could be many, many different kinds of interfaces that I want to implement. And when I implement all these interfaces in my classes, it gives me another set of tools to make more customizable child classes. So I can make more specific type of classes, right? And I can identify which of the classes that I'm looking at are similar. For example, all the classes that include an iWorkable interface, I can check the type. Is it iWorkable? Right? Is the type iWorkable? I can use the GetType method specifically for that reason. Is it iWorkable? If this class is iWorkable, then do the work, right? Update. Is it updatable? Is it updatable? Right? That's another thing I can do. So if it's updatable, then update. Call the update method. So this is another alternate that I could do, and I'll stop here because I'm going to just do one example, and then we'll stop. So what I can do is, instead of my maybe there's going to be some game objects that are not updatable. They're just static. A static game object. For example, like the background. That could be a static game object. Or a platform, right? That looks like something that the player is going to jump on. That's not going to update. It's going to stay in the same position the entire time. I'm not going to do anything with it. I'm not going to update it. I'm not going to redry it or make it go on fire or something like that. There might be some static objects that never update. Okay? So having an update method on every game object, might be wasteful. So what if we didn't do this? What if we didn't include an update method, but the start and reset method were included? Okay? Or maybe just maybe there's an iResettable, something that's resettable, right? Hear me out for a second. So what I can do in my Solution Explorer, I can create a new object, a new thing, a new class, if you will. It's like a class, but it's an interface. Add new item, and if I go to the options, I can choose interface now. This is an option. And my interface is going to be called iUpdatable. Okay, updatable. And when I call it iUpdatable, it automatically adds the interface keyword, right? iUpdatable. And maybe what I'm going to have is a method that returns void that is the update method. Okay? Okay, that's all you have to put in your interface. You don't put any implementation details, just the shape that you want the signature of the method itself. Okay? And if we change game object, right? So that not every game object has an update method, but I'm breaking changes. Here we go. But the enemy, right? The enemy. Not only does it derive from game object, but it also, I'm going to use a comma here, it also implements the iUpdatable interface. So I not only inherit from game objects, but I also use the iUpdatable interface. It's kind of the same thing. The only difference between this is I don't need the override keyword. Okay? So the override keyword doesn't have to happen. It's the exact same thing. So this is both a game object and an updatable game object. That's what it is. It's updatable. It's another way of identifying my class. There might be some game objects that are non-updatable, static game object. Okay? There might be a class that is drawable. Other game objects that are not drawable. Example, a checkpoint might be a game object where I have a position, it has a transform, but you can't see anything. It's just invisible, an invisible object, not drawable, right? As an example, that might be something I use. So going back to boss enemy now, boss enemy is also updatable. So I can say iUpdatable, right? And again, I can't use the override keyword with an interface. Okay? If that makes sense. Right? Now, one thing to note is that because boss enemy derives from enemy, and I don't have to do this iUpdatable thing because it's already updatable, because it's deriving from enemy, and enemy is an updatable object, so therefore I should use the override keyword. Right? Override should be first. This is okay, right? But It doesn't like this because there's no method to override the update method. Because yeah, I guess I just do one of these in this case. Sorry, it's language specific. What does it say? Boss enemy update has inherited member update using the new keyword if hiding was intended. The new keyword. That would mean like new update. I'm not wrong. And I think I need to make that declaration modifier like this. That's the way to do it. Hiding was intended, I can use the new keyword, right? I want to hide the update with this one. That's another way of doing it. And the new keyword does that, and we talked about that. Actually, it's in your notes. All right, and then the last thing is the player. The player is also updatable. So iUpdatable, it's also handled in the iUpdatable thing here. I know I'm running out of time here. And again, I can't use the override keyword here because it's part of the class. And there might be some game objects that are not updatable, the static game object, which I don't have yet. For example, a platform. So if I made a game object type that was a platform, I don't have that yet. Right? Platform is non-updatable. It doesn't have that. It doesn't have an update function, right? As an example. And there might be another one that's drawable, right? You know, draw. I want to draw the player. I want to draw the enemy. I want to draw the bullet. But I don't want to draw the checkpoint. I don't want to draw a trigger, right? These are all things that I can have, but I don't want to draw. Okay, so that's kind of like the that's the advantage of having something like this. Now, I have to be. I made a mistake. Updatable. What is it going to recommend? It says it's a rename to updatable. But that doesn't make sense. Yeah, that's right. Don't worry about this. This is warning me this is not spelled properly. All right, does that make any sense? So again, when we look back at the the interfaces are just, think about them as contracts. I want to make sure that I'm not using multiple inheritance. I'm just identifying or marking a class as also being something that is workable, something that has a work method, or you know, there might be something that has an update method in. It's usually related to the method that it's passing on. Methods. Normally it's like one interface, one method. You can have multiple methods here, of course, right? But like it says here, all methods are abstract, but you don't use the override keyword. You must override. You must override. Okay? It's all included. And that is your interfaces. As you can't instantiate concrete object with either abstract classes or interfaces. So you can't, I can't just make an derive, you know, from an abstract class. I can't instantiate. I have to make a concrete class from it, right? That's what it says. And a class can inherit from one base class, but I can have multiple interfaces that I inherit from. I know I'm running over time, guys. Another minute or two, and then I'll let you guys go. All right. And we're going to cover extension methods some other time. But it's interesting. Extension methods are like inherited methods, but it's like I modify the class and add a method to the class. That's what I do without actually, you know, having the class itself being updated. So instead of me defining everything in one single class, I can have partial classes, right? I can have the class defined here and then, you know, kind of finished over here, two partial classes. Or I can have an extension method that can add on to a class, almost like an add-on, right? And this is kind of like a different way of designing things with extension methods, right? It's like data-oriented design as opposed to object-oriented design in some ways, okay? And here's an example of that, which I'm going to go into. So you make, you know, your public static int add check digit, right? And what I want to do with this is add check digit is something that I want to add to the class. So I might have a class that I want to, my account number is going to have a, and notice these are static, but what I want to do is I want to add a method, and this doesn't really do it justice the way it's explained here. But basically what I want to do is I want to add a new method, right? I want to add a new method on a particular type that doesn't exist, right? So I'll explain this in more detail when we get back. All right, so it won't be this week, it'll be next week. All right, any questions around enums? We covered enums again. I know you covered enums before. We covered a bunch of stuff. We covered abstract classes and interfaces. By the way, the next assignment that you're going to get, which is next week, I'm going to have a whole new assignment. It's going to be based on abstract classes and interfaces. You're going to get this thing coming up, right? So that's why I've been covering this over the last couple of weeks, because my underlying motive is you understand how to do object-oriented programming without polymorphism at all. Then you only have one part of object-oriented programming: inheritance and polymorphism. Those are the two pieces that we covered over the last 2 weeks. Any questions at all before I let you guys go? Again, all of this is being covered online, so if you have any questions, or if you forget, you can always go up online and check my work. One thing we want to do before we stop for the day is we want to put this up on GitHub. Notice that these are all check marks. So I'm going to go to Team Explorer, I'm going to go to Home, I'm going to go to Changes, right? And I'm going to say added iUpdatable interface, right? That's what I did. iUpdatable, commit all. And then I'm going to go to Home, Sync, and Push. Okay, there we go. So, and what this allows us to do is skip updates. Like, updates take a lot of cycle time for those people who are interested in ever making games. Not every option, not every game object needs an update. Like, it's not going to move, as an example, right? Most of the times they do. It's more of the drawable types. I'm going to draw some, I won't draw the other ones, right? And I can do those separately. But I mean, you can have an iUpdatable, you can have an iDrawable, you can have an whatever, iTransformable. If you want something to have a transform, maybe some game objects don't have a transform. You want to have, you want to add some kind of, or identify a class a little differently, and I can check to see if it's of type iUpdatable. Is it of type iDrawable? Is it of type iWorkable? Whatever. And there's other ones that are built in. For example, iEnumerable. We'll talk about that as we go forward. Any questions at all around this stuff? I know some of it's a little bit confusing until you start using it. Guys, thank you so much. Then I'm going to stop recording now. I'll stick around for questions, like always. If you have time, I have time. But otherwise, I'll see you guys next week. Again, there's no lecture on Wednesday. So I'll stop recording now.